Hello everyone! Hope you're doing great. In this video, we're going to analyze capacitor behavior in a rectifier circuit and calculate the right capacitor value step by step. We'll also compare theoretical results with practical measurements. When the switch is on and the positive half cycle is applied, current flows from the transformer to the capacitor and charges it. When the switch turns off, the capacitor starts discharging through the load resistor. For a half-wave rectifier at 50 Hz, C equals VDC divided by VR times 50 times RL. For a full-wave or bridge rectifier, frequency becomes 100 Hz. C equals VDC divided by VR times 100 times RL. Higher frequency means less ripple, so you need a smaller capacitor. We need 22-volt DC output and a 1K ohm load resistor. Assuming ripple voltage is 10% of VDC, VR equals 2.2 volts. Using the formula, C approximately 100 microfarads. Now for capacitor voltage rating. Peak voltage is about 31 volts. We add 20% safety margin. VC approximately 37 volts. So we choose a standard capacitor, 50 volts. Larger capacitance reduces ripple more effectively because it stores more energy between peaks. However, it also causes a higher inrush current when the circuit is first powered on, which can stress diodes and the transformer. Full-wave rectifiers use both halves of the AC waveform, effectively doubling the ripple frequency. This results in a smoother DC output compared to half-wave rectifiers. Diodes conduct only when the instantaneous input voltage exceeds the capacitor voltage. This conduction happens in short pulses near the peaks of the waveform. Now let's build the circuit and test it. So input is 24 volts AC. Without capacitor, about 22 volts DC. With capacitor, about 32.4 volts DC. The capacitor increases DC level and reduces ripple, but also raises peak voltage. If you enjoyed this video, make sure to like and subscribe for more electronics projects. See you in the next video.